Okay, so we have here the area model probability for this problem here. We're going to use AND. So there are two jars here. We have jar X and jar M. So jar X contains 5 red balls and 6 orange and 7 blue balls. So if we add these three numbers, 5 plus 6 is 11, plus 7 is 18. So the total balls on jar X is 18. So I'm just going to write that down here. And then we have another jar, which is labeled as jar M. It contains 4 green, 2 yellow, and 8 purple. So we add everything. So 4 plus 2 is 6, plus 8 is 14. So there are 14 balls inside the jar M. So these are the total number of balls for each of the jars. So let's start with the jar X first. We find the how many R's or how many red are there inside jar X. This is jar X on this side and jar M on this side. So how many red are there in jar X? 5? 5 out of what? 18. Okay? Because inside jar X there are 18 total. And then 5 of them is 5 of them are red. So that's 5 out of 18. Next, how many orange are there? 6 out of 18. And then we have here jar X. How many blue are there? That's 7 out of 18. Next, we try to reduce if we can. So can we reduce 5 over 18? We can do that, right? What about 6 over 18? What's the reduced version for that? 1 out of what? How many 6's are there in 6? There's 1. How many 6's are there in 18? 3. So it's like 1/3, yeah? So this is pretty much like 1/3 because there's 1 and then there's 3. So that's 1/3. So we're taking 1/3 for that. And then for jar M, how many green are there? So that's 4 out of 14. So 4 out of 14. And if we reduce this, they both go with 2. So 4, how many 2's are there? That's 2 out of 7. So that's 2 out of 7. So we're trying to reduce it. So that's 2 and then 7. What about how many yellow are there? For the yellow, that's 2 out of 14. So that's 2 out of 14. So pretty much this is 1 out of 7. Because again, we reduce it. There's like 1, 2, and 2. And there's like 7 2's in 14. Purple, 8 out of 14. So that is 8. So that's pretty much like 8 out of 14. So this one goes by 2. So that is 4 out of 7. So this is 4 out of 7. Now, if we find the total for this, we add all the ones with same denominator. So 5 plus 6 is 11, plus 7 is 18, and everything is over 18. So pretty much the total should equal to 1. So the total from left to right is 18 over 18 is equal to 1. And then the total going down is like 2 plus 1 is 3 plus 4 is 7. So that is 7 over 7, which is equal to 1. So you would know that you are on the right track if the total from left to right is 1. If the total going from top to bottom is also 1. So we're on the right track. Now we are going to fill in the tables here. So what are we going to do so that we can fill this spot in here is to multiply these two numbers. So that would be 2 over 7 times 5 over 18. So let's see what that is equal to. So this comes out 10 over is 126. Can we reduce this to lowest term? This goes by 2. Yeah. So this goes by 2. So that's 10 over 126. There's like 5 2's in 10. And 126 divided by 2 is 63. So the answer for this spot here is 5 over 63. So I just show the work for that part right there. And then let's do the next one here. So that is 1 over 7 times 5 over 18. So that is 5 over 126. So that becomes, this goes by, we can't actually reduce this anymore. So 5 over 126, 5 is not divisible by 2. It's not divisible by 5. 126 is not divisible by 5. So that's the answer, 5 over 126. Now I'd like you to figure out the rest of the boxes. Okay, to get the total for each of these numbers here, all we need to do is we can use a calculator to determine the values for each of the totals here. So we're just going to add these fractions together. So this is how we set it up. So we're going to have a parentheses 5 over 63. So that's the one that I had for the first one here. And then I'm going to add 2 over 21. And then add the other one, 7 over 63. So the answer to this is 0.29 if we round it off. So this one right here is 0.29. I rounded it off. Again, it was 0.285, whatever that is, but I rounded it off. Now, please look at these values. That is actually the same value as we have right here. So 2 over 7, if we are going to get the fraction version for 2 over 7, so 2 divided by 7 is actually 0.29. So it's the same number. So this one, the green here is 0.29. So it's going to match up. So I'm going to do the rest of these other 2 rows. Okay, so what I would do next is I am going to add the total going down. Now, in order that we can check if we get it right, is if we add everything out, it should equal to 1 here. So let's see if that would equal to 1. So 0.29 plus 0.29 plus 0.14 plus 0.57. The answer is exactly 1. Okay, so the number is 1 here. And if we add horizontally as well, it should come out 1. So let's see if it would. So 0.28 plus 0.33 plus 0.39. The answer is 1. Okay, so both horizontal total and vertical total will equal to 1. So that is one way to check if we got it right. Now let's have the probability of the following problems here. So let's start with the first one. What is the probability that a person or a kid, so a kid picks 1 ball from each jar. So pick 1 ball from the first jar and then another ball from the second jar. So what is the probability that we get red and yellow? So red and yellow would be 5 out of 126. So this is 5 out of 126. So that is red and yellow. So these two are, that's the column for the red. And this is the column for the, this is the row for the yellow. So where are these 2 pens touching each other? that is the probability. So it's sitting at 5 over 126. So it's right there. Next, orange and yellow. So orange, and then I go to yellow. It's this one. So the intersection for the two pens is right here. So that value is 1 out of 21. Okay, so let's fill this in. By the way, I just noticed that this one can still be reduced to its lowest term. 7 goes to 7 one time, and 7 goes to 63 9 times. So you can have 1/9. And this is 2 over 9 also. So you can do that. That's fine. So this is 1 over 9 or 2. This is 2 over 9. That's fine. Okay, so let's fill this in. So I'm just going to go ahead and write it out here and then see if you get the same answer. So these are the answers here. So that is how we find probability using the area model and its end.